Making a video, draft science. Should have done it a few days ago. But anyway, it's a reaction to a video posted by Arkani-Hamed. Space-Time is Doomed, Messenger lectures. He says these are great lectures, great series, but, I don't know really, frankly, some of them are boring, and like the Feynman one it's really nice to see Feynman does lectures, but I mean, realistically, it's not very good science in the sense, especially his description of the two-slit experiment, for example. And the oversimplifications he's guilty of. But anyway, so anyway, this lecture will deal with this, whatever this mush is. So, it's, Arkani-Hamed is conceded, okay, that he sees some value in this idea that there's some unifying function. And the things should have causes. There's effects, there should be causes, they should be diagrammable in something besides extra-dimensional loopholes. Whatever. Gerrymandered, that's the right word, but, contrived. Made up, synthetic, yeah, there you go, synthetic solutions that aren't, they're only 10%, accurate kind of thing. They're only a facade of a solution. They're not a real solution. Say this, it's not a real description. It's like the bent space thing. It does some stuff. It gives you a visualization of impact, of what it means for something to grow in intensity and all that, but it does it inaccurately. It has nothing to do with how that happens. How nature's force punch is delivered. It has nothing to do with bending space. It has to do with real things hitting real things. So anyway, 14 minutes of blah 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 mush. And so then he starts to get to the science part. Yeah, the stuff beforehand wasn't science, really. Anyway, the philosophy of something, I don't know. So I don't know what it was. It doesn't really matter. So let's get to it. Yeah, sorry, see, my mood is just, lousy.
In the world, this particle, this interaction, and so on. Today I'm talking about the basic rubric that we think governs all of physics. Okay?
All right, so he called this lecture 3 on Space-Time is Doomed, and it's not. This is the first of 4 lectures, and the third one was on the subject of Space-Time is Doomed, and that was getting into string theory bullshit and all this black hole stuff and all this. It's real. This is proven. It's real. Okay. He says "okay" a lot. It's like Mackie or something. I mean, well, we all have speech effects, so, but this guy has his group of them. But anyway, so I don't know why he posted this video. I don't know why it's mislabeled. I just don't get it. But this is all I get is a response. You might be onto something. Here, I'll post a video talking complete crap.
So we're not going to be talking in great detail about the actual content of the world. We're going to be talking about the very basic laws that govern it. Relativity and quantum mechanics.
Yeah, it says you, right? I mean, both things that have no, at least relativity has some exactness to it. Quantum mechanics is whatever somebody says it is. Anyway, it's this equation, or it's that equation, or it's this, or, it has nothing to do. It's Heisenberg. It's not even a, it's this vacuous concept that the magical force thing has something to do with some sort of probability wave thingy doodad, because somehow we can't know what something's doing because it's not really doing something, it's doing some vacuous thing, and it has nothing to do with the fact that we have limited sense capacity to see what it's doing. No, it's actually not doing anything in the explicit sense. It's doing some, I'm amorphous and magical and I'm in some other dimension and I'll pop in and out of reality and all, and it's all It's all gibberish made in a mathematical model that has insufficient boundaries.
And as a backdrop, I want to remind you what Newton's picture of the world was.
Right. And the hard science. Yeah. So let's go back to real science, and then we'll talk some more mush about the crap we made up.
In Newton's picture of the world, imagine here's time going vertically up, and here's space. Here's a particle just sitting at rest. Okay? Doop, doop.
Okay, so right here we're in trouble. Here's a particle sitting at rest. So that's where physics couldn't get A right. Okay, I mean the fundamental part of physics, right? Physics is kind of they used to be called particle physics. But that's the whole idea of physics, is to understand what the things are you're talking about, what the physical things are made out of. So this idea of particle is sort of an important word, right? Now if I took the Earth, a solid kind of roundy object, and I said, okay, let's make that kind of a thing the definition of a particle. Then I talked about, then I labeled something like a solar system or a galaxy, and then when I talked about them I said they were particles. When you can see the clear difference between like an Earth, a solar system, and a galaxy. Very different objects, really. Solar system, galaxy have something in common, but neither of them have anything in common with this Earth thing. I mean, two flat things that are really not very dense, and this round thing, spherical thing that is very dense, very different things. So the definition of particle becomes really important. And then if if I argued that let's just change one fact in the universe and say that you couldn't make a particle in Earth smaller than like a moon or something. That it had to either be a moon or grains of sand, but it could never be anything in between. Well, how else do I want to put this? But anyway, the definition of this idea of what a particle is important, because galaxies are made out of particles. Solar systems are made out of particles, so to speak. So if you're going to identify those things as particles, then your whole physics, your whole description of reality is going to break down, because there's no such thing as an Earth at rest in the context of galaxies and solar systems. That kind of particle can't be at rest, where theoretically a solar system or a galaxy could be. So when he says a particle at rest, he's already fell off the rational boat here. He already fell off of reality. Okay, because there's no such thing in reality as a particle at rest, a real particle. The real particles, photons, are never at rest. They're always moving the speed of light. Even when they go inside your matter, they're still going the speed of light. Everything happens at the speed of light. Every interaction happens at the speed of light. There's nothing crashing into something that isn't moving. Every interaction is happening at the speed of light. All the particles are moving the speed of light. There is no particle at rest. You can have a swirl of particles that isn't moving somewhere, but the particles making up the swirl are moving. The atoms inside of a cloud, for example, are moving. They're not at rest.
Doop, doop, doop. Moving up in top.
Doop, doop, doop. It's good he has sound effects.
Time at different snapshots in time, it's sitting there at rest. Here's a particle that's...
Alright, so it's sitting there at rest. So here's I'm just saying, you can say that, well, yeah, Newton didn't have full knowledge of particle physics, okay, but he may have speculated about the very nature of what rest means, and he certainly did speculate about the transmission speed of force, and he didn't really know whether it was, I mean, instantaneous was already known to be kind of a paradox.
Moving at some fixed velocity to the right here, okay? But here's something else that a particle might do. A particle might move in some curvy fashion.
These drawings are worse than anything I've ever even done. But anyway, alright, so a particle might move in a curvy fashion. Now, photons aren't going to do that. Particles won't do that. They won't move in a curvy fashion on their own. Something has to make them move in a curvy fashion. So it might not do that. No, it won't do that unless a force affects it.
And what Newton told us is that when the particle moves in a curvy fashion, that's because it's being acted on by a force.
Right, correct.
And that force causes the velocity to change from one moment to the next. The change in the velocity from one moment to the next is the acceleration. And
right, so again, we're saying particles have acceleration. And again, the argument is no. In physics, the fundamental mechanism doesn't have acceleration. What you can do is accelerate the speed of the spin, the rotational speed. You can change in what direction they're all going. So if they all happen to go in the same direction, then you'll get a velocity. I have a bunch of particles in me. I'm not moving relative to my environment because my particles have exactly the same proportion of extra ones going in one direction as everything in my environment right now. That's why I'm going exactly the same direction and way they're going, is because we all have the same imbalance, exactly the same extra bits in a direction. And to change my velocity, to give me acceleration, is all you're doing is changing that balance to a different balance. Now that's the simple answer, and it has to do with real particles. And those real particles don't change their speed. The collections that the particles in change their speed by changing the identity of them. By changing, you can almost look at it genetically, like racist in a way. You could say the race disposition of what I'm made out of genetically gets changed. I end up having more European or more North American or more some other kind of thing inside of me, and that moreness in some other orientation changes the direction I move in. But that's how you change direction. You change the physical thing that you've changed the direction in.
There's this famous equation, F equals ma, that tells you exactly how that velocity changes.
Right, none of your new physics has changed any of that. This isn't, you've not undone any of that as a truth. So why are we doing this?
One instant to the next. Okay? So in this Newtonian picture of the world, all you have to do is specify at any given moment, where are all the particles, how fast are they moving, and in what direction? Go. What are the forces? Go. And you'll be able to predict everything that happens in the universe after that, simply by applying these laws of motion. Furthermore, the nature of the forces were that they were extraordinarily...
Right, so the point is that, yes, the nature of the forces is part of the particle reality. Again, photons, we don't consider them a force, but clearly, if you were to say, let's freeze the universe as it is, you'd have to freeze photons in their transition. And all the forces are made out of the same kind of substance. They're not made out of nothing, they're made out of something, and they would be frozen in their position also. So you're not undoing determinism by playing this game as if somehow Newton was wrong. The only thing Newton didn't understand was that, yes, there is a fundamental particle.
Simple and beautiful. The force of gravity, for example, was described by the existence of a force on this particle 1 by the presence of particle 2 that was proportional to his famous constant g times the product of the masses divided by the distance between them squared. Okay, so there's extremely simple forces acting pairwise between particles, which together with specifying the initial positions and velocities would allow you to predict everything.
Right, and you really haven't undone any of that. It's just as you get smaller and smaller, it gets more and more impossible to understand what the condition actually is. So the more detail you're needed, the more detail that becomes relevant, the finer the grain, the more unpredictable the result is. But just as I can predict the function of this video, or I can predict that my shirt isn't going to explode, those predictions are reliable.
Note also that this picture allowed a very interesting notion of an action at a distance. Didn't matter how far away that particle was, it would still exert a force on you.
Right, so that's the argument, that somehow Newton wasn't aware of that, and I think he was fully aware of the question of the propagation of force and the problem it raises of communication, instantaneous communication over long distances. Doesn't go anywhere reasonably, and it creates a paradox.
if the particle was 10,000 meters away and you moved it over there, then instantly over here you would feel the force changed, right? It's now pointing in that direction rather than in that direction. So there's a notion of an action at a distance.
Well, you're saying it's a notion. I'm just saying it has nothing to do with any of these equations. It has nothing to do with Newton's science. So why even bring it up? I mean, obviously Newton didn't have the faculties to do everything for you. So yes, you had to figure out some things on your own.
This was this clockwork picture of the universe.
Yes, and there's nothing wrong with that clockwork picture except your misidentification of the fundamental physics of physics. You know, making all the wrong determinations about how it functions. You have a choice: particle, wave. You choose waves instead of particles. You have a choice: physical explanations or magical dimensional explanations. You choose again wrong.
Really allowed you to predict everything. There was no part of the universe that wasn't accessible. No part that...
Well, it's just a preposterous pile of crap. Yes, theoretically. And it's still theoretical. You're never going to make the ruler that can measure the smallest particle. It's never going to happen because you can't make the scale small enough. You can't. There's nothing... If you got to... It's like the photon argument. Photons have to bounce off something for us to see them. You can't bounce photons off of photons to see photons, because obviously that's like crashing a Volkswagen into a Volkswagen. You're not going to see the Volkswagen you hit because the Volkswagen's going to bounce back and tell you something. You have to hit things with smaller things. You have to measure things by hitting them with smaller things, and we don't have smaller things. And he even gets that all wrong, because he talks about measurement as if you need bigger and bigger and bigger hardware to measure things. We only need bigger hardware because we have to have big hardware to make small things, and that's the problem. But the small things are what does the measuring. And you can't make smaller things than the smallest thing. So therefore you could never measure the smallest thing.
Couldn't be understood and predicted. Okay? All of that's going to change, of course.
Yeah, well, none of it changed by any fact, by any real evidence. So, yeah. It just changed because you all got engaged in telling stories, little Red Riding Hood and Hansel and Gretel stories about reality and bending space and nothing telling something what to do, and magical sources of energy. We can move the earth now by just creating a fake dimension that has an infinite amount of energy that we can put anywhere we want to, any place we want to. It's just crap.
So let's first review how Einstein changed part of this. So Einstein's name is famously associated with the principle of relativity, but what's sometimes not appreciated is that actually relativity is not an idea that goes back to Einstein. In fact, even Newton's laws had a form of relativity that even predated Newton.
Yes. Well, quite obviously, there's always a relative association between things. There's always a connection where you're going to be locked by forces that are stronger, and then further away they're weaker. But how else to even say that? There's a consequence to the fact that things take time, and that I can snap my fingers and somebody 10 feet away can hear me snap my fingers. Somebody 10 light years away can't hear me snap my fingers. Duh. So yes, Newton conceded relativity, but only in the sense of it didn't mean that it created extra dimensions, fake dimensions, that all of a sudden are created by distance.
Himself. It was Galileo who first realized that this notion of relativity existed. What's the idea behind relativity? The idea is that, let's say...
No, what the idea behind relativity is this fake concept that you as a measuring device don't get changed by your velocity, so that you can move in an elevator going 3/4 the speed of light, and you're still seeing photons the same exact way. You haven't changed at all, even though your matter is going 3/4 the speed of light, even though 3/4 of your atomic bits, your real particles, have to actually be moving in the direction you're moving, and only 1/4 of your particles can be ever doing anything sideways or any of the other orbital maintenance that's required. If I move a galaxy 3/4 of the speed of light, you can sort of understand that the bit's going the wrong way, or the bit's going this way and that way. The bit's not going the speed of light are going to have a real hard time keeping up, aren't they? You can figure that out, can't you? And that's time dilation, in that obviously the galaxy isn't going to spin as often in the same amount of time if it's got to go 3/4 of the speed of light in a direction. Fact. And that's all this relativity crap comes down to. You can believe that time is bent and everything's warped, or you can believe that the galaxy, if you try to move it 3/4 of the speed of light, all the bits not going in that direction that you're moving in are going to have a real hard time keeping up.
Let's say I drop a ball, and I just drop it straight down. Then I know that after 1 second it'll have fallen 5 meters. After 2 seconds it'll fall 20 meters. 3 seconds.
All right, well, we've got nailed it. This is, I'd say it was worth playing, but it's really not. It's just the curve space argument being made out of the fact that there's parabolas involved in terms of acceleration of gravity, and so it's this whole bent versus straight line bullshit. And we know the ball doesn't travel the curved line, it travels a straight line, but whatever, it doesn't really matter. Let's move up to something more interesting. Hopefully, maybe not, but we'll see.
Light hits one end of the box at the same.
Okay, simultaneously. This was the part that was really annoying, because this is just so fundamental to the wrong interpretation of what happens when you do experiments at high speeds. And so they're almost arguing that you get rid of the idea of simultaneous because you're moving in an opposite direction to the thing you're watching, and therefore you can watch its ending before you see its beginning, or some other kind of notion like that. And obviously none of that will happen in actual reality. If you actually do the experiment, there will be no loss. Two simultaneous events will still be simultaneous in real time. All right? What you see based on the fact of your movement doesn't have anything to do with what actually happened. It has to do with your broken perception. And again, you're not even going to see these things in any kind of normal seeing way. Events that are projecting photons forward are going to be very different than events projecting photons towards you. And because you're moving 3/4 their speed, you're going to end up meeting them much sooner, okay, as photons. But you're not going to change their velocity any. What you're going to do is change their frequency. You're going to shift them. And the truth is, you're going to interact the evidence of what happened at different periods of time based on which direction you're coming from, because the things happening are projecting their photons in different directions to your motion. But it's just such a wrong way to look at it.
Time as the green light hits the same other end of the box. The word simultaneously makes an appearance. Okay? They're happening at the same time.
So you use the foundation of these bogus experiments where they say they create two, paired photons, and then they send them in different directions and they're identical except one's up and one's down, or some other kind of bullshit. And these are all presumptions built into these experiments that aren't actual things you can talk about as being facts. They're just things they've assumed to be true. And they're really assumptions. They're just really not very much founded on anything called evidence. They're just hoping or figuring, or because the math says it's possible. But it's not anything to do with anything like, I have hard evidence that that's what took place. I don't even think they have theory. I don't even think they really actually have any real evidence to say they can do any of this stuff with enough precision.
But if it's true that there's a maximum speed, and that speed is the same for all observers, that is a fake notion. Because imagine the box was moving that way. Well, that speed is always the same. It's always 300,000 kilometers a second, and that end of the box is running towards it. That end is running away from it. So the red light hits that end before the green light hits that end. Or imagine the box was going the other way. Then you reverse the...
It's not a very good... The boxes aren't even drawn very well, but it's like moving the box and two things moving, blah, blah, blah. And yeah, well, the real truth is that if you're moving towards a source of photons are moving away from a source of photons, it will change at what time you'll receive the photons. Their movement is real and static, but so is yours. And yours, you will get to the light sooner if you're running towards it. It'll hit you in a time interval that's changed. And that's a fact. And it's not because the light moved faster or slower. It's because, yes, the relative distance it had to travel changed. I mean, duh. There's no magic here.
Order in which the events happen. Depending on your state of motion, depending on whether you're at rest relative to the box, running relative to the box, you will come to a different conclusion about what...
Right, and your conclusion is based on your broken sense perception, and you can just admit that. I, obviously, because I'm moving at preposterously fast speeds, watching things moving at preposterously fast speeds, probably can't see anything reasonably in any kind of scale. And so you just to concede the point. Your instruments are broken. This is nothing complicated. Alright, so we'll move on to another bit. Yeah, I'm really not, it's just irritating.
My hand, it will decay and disintegrate in 2.2 microseconds. Okay? So it disappears.
Okay. So now he's doing the muon thing, and now somehow this proves the time dilation relativity version of it. And no, it just proves the fact. Again, if galaxies had a decay amount, how much stuff flew out of the galaxy based on how many times it goes around. So once it goes in one spiral, it shoots out a certain quantity, a certain number of photons or amount of radiation. Yeah, the faster I move it, the slower it spins, the less radiation it produces. Duh. Hello?
Hi, this is Josh from the customer service department. Can you hear me okay?
Oh, I think you're lying, Josh. Yeah, Josh from the customer service department of no company. Yes. Cool. The other fourth dimension, third dimension, whatever. Yeah, fourth dimension, right. He's from customer service in the fourth dimension, in space-time.
Really, really fast. If I just took it and I threw it really fast and ignored this time dilation effect, there's no way that it would make it from the upper atmosphere down to the Earth. It would just disintegrate too quickly. But precisely because it's moving really fast, this effect stretches out its lifespan. Okay? And that's how it manages to make it to the ground.
Right. So he's talking about muons going through the atmosphere and blah, blah, blah. They have an accelerated speed, and the accelerated speed, because they're a complex thing, they're not a particle, they're a galaxy. And so they rotate less because more of their little bits are now going in a direction, a different direction, one direction. And if they're going in one direction, just as the little bits in like the stars and the solar systems and all the little bits inside of the galaxy, if those little bits are all of a sudden going as fast as they can in just one direction, well, they're really not doing this rotation thing in any kind of coherent manner, are they? And if that thing is to hold any kind of balance, well, then there's got to be some mechanism that transfers that speed difference to the perpendicular bits that are moving some other direction. So there has to be a mechanism to drag them along. And that mechanism is essentially the disappearance of a part of your material form for a portion of time, so you can do this maneuvering. It's like dancing, and then I ask you to move at some fast speed to your right or left. It's essentially going to be, you're going to have to stop dancing to do that movement, and then you can dance a little bit, and then you can move, and then you can dance a little bit, and then you can move. That's our reality. That's how things have preposterously fast speeds, and that's time dilation. You degrade the metabolism, the function of the matter, when you accelerate it to very high speeds. And if you just think about the idea of moving a galaxy the speed of light, maybe you can recognize that if the galaxy's moving the speed of light, no piece of the galaxy could possibly be going any other direction. No planet, no solar system, no piece could possibly be going in any perpendicular direction or any other kind of direction, because then it would have to be moving faster than the speed of light to be able to do those two velocities. Right? Certainly going the opposite way would be verboten. You couldn't possibly be going the speed of light and still maintain an orbit by going the opposite way of the speed of the direction you're moving. Certainly couldn't do that, could you? No. Not possible. Simple, really.
This is real.
No, it isn't. You can keep saying, this is real. No, it isn't. I'm sorry. The story was made up 100 years ago, and it continues to be just a made-up story. And because you've all fell for it, and you're all playing with it, and you're all saying, this makes sense to me, that somehow when something gets velocity, somehow it goes into magical time dilation space, and now it's a magically different thing. No, it's different because it's physically changed. It's not in a different space. It's not in a different location. It's not in a different surrounding. It's in a different condition. It's broken. If I move a galaxy the speed of light and say the galaxy produced something like love every time it did a spiral, it wouldn't be producing any love anymore. It would be broken as a love producer. These people really, they're too smart to be this stupid. Frankly. This is stupid. This is real. This is real, okay? This is real, okay? This is real, okay? No, it's not okay.
Is a few billion years later, the universe has doubled in size. That means that there's space being invented constantly at a fixed rate between all these points.
Right, so this is another thing where, he even concedes that it has to be all the space. That means the space inside of atoms and the space inside of everything. I don't think there's any evidence of that, and it just breaks the whole force dynamic. Because if you don't make the particles bigger, but you make the space bigger, the interactions are going to get weaker and weaker and weaker and weaker and weaker and weaker and weaker. And the universe is going to fundamentally change in how it functions. And there's just no evidence of the universe being something that's constantly, having to readjust to new conditions. There's ever a bit of evidence that the universe is just slowly dying. It's slowly, whatever it's doing, it's just slowly falling into it. It's not being harassed at all. So another, what? Bullshit. Sorry. Maybe your math says that, but it's wrong.
And this picture was completely smashed by quantum mechanics. So
let me move back.
There's a variety of slogans
okay,
like this
I think
that it signaled the end of this dream that began with Newton, that there was a clockwork universe where we could predict, if we knew everything, at least if we knew everything about what was going on at a given time, we could predict everything everywhere in the universe later. Okay? There's this picture.
So his argument is that somehow they have proof that there is no determinism to the universe, that there is some sort of randomness, that if I set up the universe exactly the same way, with all the forces in the same position, all the forces at the same intensity, everything exactly the way it is, that it won't do exactly the same thing every time I press the on button. No, that you have no fact. Okay? You just don't. You don't have a single fact proving your magical photons who don't know where they are your magical whatever inside of atoms that pop in and out of reality. They go to the fourth dimension and they pop into this dimension, your virtual mishmash. There's no evidence of any of this crap, and yet you say this is real. Real why? Because you believe it. It's a frickin' religion. You're a frickin' preacher of a religion, not scientist.
Of determinism. And this...
So he's saying determinism is dead. We've proven it. Not even fucking goddamn close.
Picture was completely smashed by quantum mechanics. So there's a variety of slogans.
Yeah, well, whatever. It really wasn't. It's certainly not smashed by any nonsense that there's not a rational explanation for the the minor defects that take place in very special circumstances and very, very special experiments. But we kind of know from the rest of the world that it's all bowling balls.
Slogans that go with it that you've probably heard of. For instance, there's the uncertainty principle. This is just one big blow to this idea of determinism. Remember, Newton tells you that to predict what goes next, you have to give me at a given time where the particle is and how fast it's moving in what direction. The uncertainty principle says, that's impossible, I'm sorry.
Yeah, well, the uncertainty principle is crap. There's no uncertainty about the light coming from billions of light years across space. How come there's no uncertainty? How come the fucking photon can go 10 billion light years across space without fucking get lost in uncertainty mush? Oh, that's right, because it's not interacting with anything. So clearly it's interacting with something that causes what's called uncertainty in its trajectory. But even Feynman would concede that, no, once it interacts with something, I can tell you exactly what it's going to do. When a photon goes into an electron, I'll draw you a fucking Feynman diagram of exactly what the fuck it's going to do. It's not uncertain. It's fucking certain. So what are you making this lie out of uncertainty? There's no uncertainty. There's a couple of fucking experiments that have you assholes confused. And that's it. But everywhere else, it's quite goddamn certain.
You might be able to ask the question in the English language. Where is the particle and how fast is it moving? But it's a meaningless question.
Oh, fuck you. No, that's just too stupid. It's not a meaning. It's the only thing that matters. Where it is and what direction it's moving and how fast it's moving, that's everything. And frankly, in the real universe, you don't even have to ask how fast it's moving. All you have to do is ask particle, which way is it going? Because that's all there is. And polarization. As the add-on. So anyway, enough of this stupid video. So again, I don't know what Hofladay's point is. I don't know. You know, he thinks this is the truth. This string theory crap. Preacher of. But I don't understand. So anyway, till next time. Fuck. This is crazy. I mean, this stupid frickin' this, you know, whatever, magnetism guy, doing all his little diagrammy crappy, and he's playing with his little Faro cell, which, you know, I don't fully understand exactly. I think it works by creating a kind of a cheap fiber optic in the chemical, you know, and then the channel of stuff is able to be bent, so it creates channels. It tends to want to create, like, you could think of it as pieces of spaghetti going across from the light, and those channels get created, and then the magnetism bends the channels. But so, you know, but they're distorted. They have their own. It's like the field lines of a magnet. Part of those lines are created by the creation of the field line itself, because that creates a magnet. And the field lines are basically can't blend into each other because they are always stuck with the problem with half of you I hate. You know, I like half of what you got, I hate half of what you got. So they just can't join, because until there's more like than dislike. And that's the trick of magnets. They have to be in the right position to be joined where they can't see the part they don't like. The part they don't like has to be in the back end. That's why the iron filings will stand up. I mean, you know, there's, you know. But look, I mean, it gets relatively good ratings for just saying mush. I mean, no real explanation of how exactly things are pushed together. Fantastic. Nice. Very interesting. Well explained. There's no hope that this is a good explanation or well explained. It's the same crap. Keeps just talking about crack whores. Mother Nature's not a crack whore. Well, she is in your world, because she's doing all this fiddly faddle. All this mush. This vaporous movement caused by perturbation. Perturbation did it. Not good enough. Not even close. Anyway. So, it's very discouraging. Everything is just... Sorry. I mean, I could, when I make videos, I could just lie and say, okay, just be upbeat and be this and be that and be I don't, yeah, but fuck that. I just don't really feel like putting on a show. So, yeah, I'm depressed and I'm sick of this shit. Yeah, so it's sort of leaking into the video. So everybody's a fucking idiot.